Hello everyone, now we have to discuss interconnections of networks. In this we have to discuss series connection, cascaded connection and parallel connection. First we have to discuss series connection of two networks. Okay, so this is network A, this is network B. These two networks are connected in series. So in this type of series connection, the use of Z parameters is highly useful. We have to write that point. The open circuit impedance parameter impedance parameter is highly useful in characterizing the series connected two-port network. Right? So in this open circuit, impedance parameters are highly useful in characterizing the series connected two-port network. So here we have what? Two networks which are A and B. In this we have what? The current through this port 1 is I1A, like that. From port 2 we have I2A. Then across network A we have V1, like that, V2, V1B, V2B, right? So first we have to write all input and output currents and voltages for a network A, like that. What is the value of voltage for a network A? You can have V1A. Let us say it is V1A. It is what? We are using impedance parameter representation. Therefore Z11A, that is the current I1, right? Further I1A plus Z12A. Now it is what? I2A, right? Then coming to V2A, which is equals to what? Z21A I1A, right? Plus Z22A I2A. That's it. Like that for a network B. For a network B, we have to write V1B, V2B, right? Which is equals to Z11B I1B plus this is Z12B I2B, like that. V2B, which is equals to what? Z21B I1B plus Z22B I2B. That's it. Coming to currents, what about currents? The interconnection results the current in each branch, that is I1, which is equals to I1A, which is equals to I1B, like that. I2, which is equals to I2A, which is equals to I2B. That's it. We all know that in series connection current is same, voltage division takes place. Like that in parallel connection voltage is same, current division takes place. Therefore what is the equivalent voltage from this input port 1? That is, for example, V1, that is nothing but V1A plus V1B, right? Like that. V2 is nothing but what? V2A plus V2B. Now we have to get the voltage. first we have to get V1, which is equals to what? V1A plus V1B, right? That is V1A is nothing but what? Z11A I1A plus Z12A I2A. That's it. Coming to V1B, we have what? Z11B I1B, like that. Z12B I2B. That's it. So from this, current is common, right? Let us say this is I1. From we have what? Z11A plus Z11B. Then from this is I2, right? I1B, I2B is nothing but we have assumed as I2 because it is series connection. Therefore we have what? So 1 component is completed. Then Z12B plus, sorry, Z12A first. Like that, Z12B. That's it. Similarly, for V2. V2 is what? V2 which is equals to we can write V2. Next V2 which is equals to what? V2A plus V2B. From this V2 which is equals to what? Z21A plus, where is current? Z21A plus I1A, right? Plus Z22A I2A. So this part is completed. Plus coming to B network, Z21B I1B plus Z22B I2B completed. Therefore V2 which is equals to, from this I1 is Z21A plus Z21B. From this we have I2 Z22A plus Z22B. That's it. So we have V1, V2. We all know that in series connection the total voltage should be equals to V1 plus V2. Here we are considering two networks, therefore we have V1 plus V2. If we have n number of networks which are connected in series, obviously it is what? Total voltage should be equals to V1 plus V2 plus V3 up to so on Vn. So we got for the series connected two numbers, a series connected two number two port network. What is the voltage here? V1 which is equals to what? Z11A plus Z11B I1 plus Z12A plus Z22B into I2, right? We have 1 1 1 1B 1 2 1 2, sorry, this is 1 2. Coming to V2, what we have? Z11 just Z21A plus Z21B into I1. Simple. Z11 I1 plus Z12 I2. Next we have what? Z21, like that Z22. Now Z22A plus Z22B into I2. That's it. We have I1, I2, I1, I2 form. So this is the governing equation what? For impedance parameter representation. Therefore, in matrix form we can write V1, V2, right, which is equals to, we can write here what? Z11A plus Z11B completed. Next Z12A plus Z12B. Next Z21A plus Z21B. Now it is Z22A plus Z22B. This is what? I1, I2. So from this we can conclude that what? Thus it has been observed that the overall Z parameter matrix for series connected two-port networks is simply the sum of Z matrices of each individual networks. Thus it has been observed that the overall Z parameter matrix for series connected two-port network is simply the sum of Z matrices of each individual network. So this is the summary from this analysis. Okay, that's it. This is for series connection. Next we have to discuss cascade connection. So this is the connection of cascade. So in this, in series connection, Z parameters are highly characterized parameters. In this cascade connection, ABCD parameters are highly useful. Highly useful in characterizing cascaded two-port networks, right? So we have two networks here, X network, Y network, in that which are connected in cascade manner. Okay, from this we have V1X, which is nothing but what is the governing equation for ABCD parameters? Input voltage, input current, that is V1 is equals to AV2. We have to write here, it is V1 which is equals to AV2 minus BI2. Like that, supply current which is equals to CV2 minus DI2. That's it. Based upon these equations, we have to get the two connected cascaded result. Therefore, first for the network X we have to get. Okay, that is V1X which is equals to what? AX which is nothing but V2x. See the governing equation. This is Bx, then I2x. Next, I1x, which is equals to what? Cx V2x minus dx I2x. That's it. Sorry. Next, for the network Y, V1y, which is equals to what? Ay V2y minus by I2y. Like that, I1y, which is equals to what? Cy V2y minus dy I2y. Therefore, for cascade interconnection, for the cascaded connection, I1, which is equals to I1x. See, the current I2x is nothing but what? This is nothing but I1y, which is nothing but minus I2x. See the current direction in this. Then I2, which is equals to I2y. You have observed these currents in that connection diagram. Okay, there is no confusion in that. Like that, V1, which is equals to, we have V1x, like that. V2x, which is nothing but what? V1y, right? The output of the first network should be equals to input of the second one, like that. V2, which is equals to what? V2y. So based upon this, the overall transmission parameters T parameters for the combined networks as shown in matrix form. Okay, we have, what is the input? This is I1, right? Right, which is equals to V1 is what? We all know that V1x, because the first network is x, right? That's why I1x, clear, which is equals to first network is nothing but AX, next BX, CX, DX, right? Then we have what? The output of the first network is nothing but V2x, right? Like that, this is what? I2x. See, here V1 is nothing but for x. The output is nothing but V2x, which is equals to V2 minus I2x is nothing but I2. Later for network Y. So from this, which is equals to, we are having AX, BX, CX, DX, which is V2x is nothing but what? Input for network Y. So this is the output for network X. At the same time, this is also input for network Y. This is the current output for network X. Like that, this is the input for I1 of Y. That's it. Okay, from this, we are having AX, BX, CX, AX, BX, CX, DX into AY, BY, CY, DY. And this is what? Now we have what? V2y minus I2y. Similarly for network Y, so which is equals to A, B, C, D into, we can write Vy minus Iy, that's it. Clear? See here, V1x is the input, I1x is the input current. Like that, we here we are what, Vy minus Iy. Therefore this you can write net AN BN CN TN, that's it. Okay, where net value, which is equals to what, AX PX CX EX, this is what, AY BY CY EY. Thus, the overall ABCD parameter network matrix for cascade network is then the matrix product of ABCD matrices of individual network. Thus, the overall ABCD parameter network matrix for cascaded network is then the matrix provided matrix product of ABCD matrices of individual network. This is for cascade connection. Next we have to discuss parallel connection. So this is the parallel connection. So in this current division takes place, voltage is same, right? For network A, like that for network B. For network A, we have current I1A, which is equals to what? We have to use, because these two are connected in parallel, it's better to use admittance parameter representation. I1 to A, E to A, like that I to A, which is equals to what? Y21A, V to A plus Y2 to A, V to A, that's it, right? For network B, we have what? I1B, which is equals to Y11B, V1B, like that Y12B, V2B. Here we have what? I2B, which is equals to Y21B, V2B plus I22B, V2B, that's it. For the parallel connection, V1 which is equals to V1A, which is equals to V1B, like that V2 which is equals to V2A, which is equals to V2B, like that. For current division takes place, therefore I1 is what? I1A plus I1B, like that I2 which is equals to what? I2A plus I2B, that's it. So I1, first we have to get I1, later I2. Therefore I1, which is nothing but what, I1A plus I1B, is equals to what? Finally we can have I11A plus I11B, current which is V1, like that Y12A plus Y12B into V2. That's it for I2, which is equals to I2A plus I2B, like that I2, which is equals to what, Y21A plus Y22A into V1, like that Y22A plus Y22B into V2. That's it. Finally what we have, I1 I2, right, which is equals to Y11A plus Y11B, like that Y12A plus Y12B. Here we are having Y21A plus Y21B. Here Y22A plus Y22B. That's it. Here V1, V2. So this is for parallel connection. Thus the overall Y parameter matrix is then simply the sum of bimatrices of each individual 2-port networks. That's it. We have what? Series connection, cascade connection and parallel connection. That's it for connections of 2-port networks.